Hi everyone, welcome to another Geometry Nodes tutorial. In this video we will learn how to create a trailing lights using geometry nodes. The idea comes from the PS5 Pro presentation last September, this one, and I decided to recreate it. So let's get started. From this empty Blender scene, press Shift A and add any object of your choice, and then split the layout. Then go to the geometry nodes editor and create the new setup. We will start by making an L-shaped curve, and let's make it procedural so we can adjust it later. Add a curve line node, and we will make this first curve straight to the right. So set the YZ axis to 0 and the X axis to 1. Then duplicate this node with Shift D and set its start point to match the end point of the first curve, which is 1, 0, 0, and set its ends to 1, negative 1, 0. So to show both curves at the same time, we can use join geometry node to combine them together. And to make it procedural, we will use a value node and a combine XYZ node to modify the start and the end points of both lines at the same time. So plug in the combine XYZ node to the points that share the same value, the end of the first curve and the start of the second curve. Then plug the value node to the x-axis and set the value to 1. Then duplicate with Shift D, goes to the end, and set this to -1. Lastly, plug it again to the x-axis. This way we can adjust the shape by changing just one value like this. We have joined these two curves using the join geometry node, but even with the join geometry node, they are actually still two separate curves. To really merge them, we will use this stack of nodes, a curve to mesh node to turn them into mesh, then using the merge by distance node to merge the intersecting vertices, and finally we will convert it back to a curve using the mesh to curve node. Click on the node and press H to minimize the node, and we can stack it up like this to make it more cleaner. Next, let's smooth the corner of the curve using the fillet curve node. This node can be used to add a bevel to a curve. Set it to poly so we can have more options. So count is for the number of vertex that reside on the corner, and radius is to adjust its distance. Lastly, for this curve, you can add this node or skip it, it's okay either way, since this node actually doesn't contribute to the end result. So, by using viewer node and plug in the index value to it, we can see the index number assigned to each vertex of the curve. And as you can see, the vertices is currently cluttered on the corner. And if you can see the index number, then you need to activate the attribute text option on the viewport overlay menu. So to redistribute it, we will use a resample curve node. Set the count to 64 to accommodate the roundness of the corner. And this way, the distance between each vertex is now even. Now that we are done with the right side curve, we will use this node setup to create the left part. Simply by duplicating this node by pressing Ctrl Shift D, then use another join geometry node to combine the two curves. And finally, add a math node after the value node and set it to multiply and change the value to -1 to flip the curve. We can clean up these nodes by making a group. So select these nodes and press Ctrl G to group it. Then press N to show the right panel. Go to Group tab and give a name to the node group. And press Tab to return to the previous node setup. With group node available, we can delete this node, duplicate the group node, and plug the multiply node into the join geometry node. Okay, for the next section, we need to stack this curve that we made along the z-axis. So we will have several copies of this curve stacked on top of each other. Let's make some room for the upcoming nodes. We will use a node called instance on points. Basically, this node allows to place any geometry, like the curve that we made, on each vertex of an object. For example, if we add a curve line node and show the attribute text, you will see that this line has 2 points. I'll use a point geometry as its instance to make it more visible. Then later we will replace this points geometry with the curve that we made. So now our task is to 1. To populate more points along the curve line, 2. Make sure that the populated points not intersecting with each other, and 3. Add a little randomness to the points positions. For the first task, we can populate the curve using curve to points node. The counts option gives us the ability to adjust the number of points. And for the second task, we will use merge by distance again to merge any intersecting points. And for the last task, we can add randomness by using the set position node and adjust its offset. Be mindful that we need to place this node before the merging, because as the points move, it may cause new intersections. By placing the node here, the points will be merged after we randomize the positions. To make each individual points adjust differently, we will use the random value node and plug it into the offset. Change it to float value, and we can adjust the range here. I use the range between negative 0.1 to positive 0.1 so that the randomness is subtle and more centered to 0. If you want to adjust it along a specific axis, you can add a combine XYZ node and plug the random value to the axis. You can plug it into 1, 2, or all of the axes like mine. It's entirely up to your creativity. To control the strength of the adjustment, you can add a multiply math node here. Let's clean up the space a little bit. And finally, with all of the random points, we can plug our L-shaped curve to the instance, replacing the points geometry. You can adjust the value as needed. I modified the point count and the merge by distance value to make the curve lines denser. Now for the last part of the geometry nodes, we need to turn our curves into a mesh of cylinders. We will use the curve to mesh node and a curved circle node as the profile. Change the circle radius to a really small number, around 0.001. And finally you got your curved cylinder. And that's it for the geometry nodes. Now we need to prettify the mesh with the material. So first add a set material node here. Then go to the material tab on the properties panel and add a new material. We will assign this material to the set material node. The material is quite simple. What we want to achieve is for each individual cylinder to have a color. And each cylinder will have like a headlight, so it looks like a shiny shoelace. Let's go to the material editor now and use the render mode so we can preview the material. We will start with the wave texture. Actually, if the cylinder were just a straight line, it would be much more simpler. We would only need to change the wave texture direction to y-axis, then scale it down to 0.5 to make the wave bigger, and change the wave profile to solve. And by using the color ramp, we can get the desired color pattern. But since there's a curve, the wave doesn't naturally travel along it. Instead, it moves along the y-axis based on the global coordinates. You can see it by moving this phase offset value. So, we need to modify the input vector of the wave texture to make it travel along the curve. We can get that vector value from the geometry nodes. Let's go back to the geometry nodes again. I'll split the panel first, then go to the geonodes editor. Make some room for the nodes and add this store name attribute node. This node function is basically to store a value. And we will store a vector from a node called spline parameter. The vector is a value available along the curve, ranging from 0 at the start point to 1 at the end point. Let's name the attribute param. We will use this information later as the vector value for the wave texture. Now combine the panel first. Finally, we can plug the vector into the vector input of the wave texture by using an attribute node. Set the name to the one we created on the geometry node. We will need to animate the wave later on, and we will only need to animate the phase offset of the wave texture. But first, to make it more interesting, we will randomize the head position of the cylinder and randomize the speed of the animation for each cylinder. We can do this by using the random from the object info node. This node gives us a random grayscale value for each object. By multiplying that value and plugging it into the phase offset, we can randomize the intersection between the black and white of each cylinder, like this. And if you increase the multiplier value, the difference will be more apparent. So here is without the randomization, and here's with the randomized value. And to move the color along the cylinder, we can use a matte subtract node to adjust it. And as you change this value, you can see that the speed on each cylinder is the same. So to make it varied, we just need to use this random from object info node again and multiply it and plug this into the subtract node. The speed should now differ across each cylinder. Now to apply some animation, we will use a simple driver. Just write #frame divided by 5 on this multiply value, and we will now get a continuous animation. So #frame is a reserve variable in Blender to get the current animation frame. And with that, to change the speed, you just need to change the divider. But first you need to delete the driver, or else it will not work. Now that we have the color pattern that we want, we will change the cylinder from this to this. So first use this color ramp. This will be used to control the alpha input to create the pause between each light. So plug it to the alpha on the principal BSDF node. Next, to create the tip of the cylinder, we'll create it by adding another color ramp. This one will control the emission strength, so plug it to the emission strength on the principal BSDF node. And then squeeze the dark value to the right, leaving it with a little space for the white value. Then use a matte multiply node to adjust its brightness. Around 25 should be bright enough. After that, use Ctrl+Shift+D to duplicate the color ramp. This one also to control the emission, but for the body and the tail part. So revert the black value to its default position. Use multiply node again to control its brightness. This one should be dimmer, so around 1 is enough. And then slide the white value to the same position as the black one from the previous color ramp. Use matte add node to combine them together. Lastly, to create different colors, we can utilize the location value from object info node to get different position value of each cylinder. After that, we will use color ramp to make the gradation. Plug this color result to the emission color so we can see the render preview. From the location value, we only need the z-axis since we will differ the color vertically. So use the separate XYZ node to extract that. By setting the color ramp mode to HSV, we can get multiple gradations that we need. Here's the hex code for my color gradation. and then plug the color result into the base color in the principal BSDF node. And we're done. Now we just need to add a cool object at the center, and we will be having a blazing trail of light coming from the rear. And that's all for the tutorial. I hope that you learned something new, and if you enjoyed the video, feel free to subscribe, like, or give some comment. This will also encourage me to make some more, hopefully even better content. And if you would like to support me, I've made the project file available on my Gumroad.